Okay, welcome to AP Computer Science A class. Today, by request, I'm going to show a demonstration of assignment number 1 from term 2 from Adhesive, the dashboard. So we've been learning how to make objects or classes, and this is one activity where you're going to make a class that behaves like a dashboard in a car. So let's look at the assignment description first, and from that we're going to write notes to design our object and then begin to design the object. So over here on assignment 1, dashboard, we're going to create a dashboard that has a speedometer, an odometer, and a check engine light. We were going to name this class dashboard, and they say download the dashboard Java and add the following constructors and methods. We're not going to download the dashboard Java. Actually, we should. So let's download the dashboard Java, and we're going to save it somewhere. I'm going to save mine in the adhesive folder, and this is unit 5. Oh, here it is already. Look, I've saved it already. What a deal. I've also saved the dashboard runner file. So there are 2 files that Adhesive asks you to download. Let's look at those files. One is the stub of the class itself, dashboard Java, and the other one is a runner, which will test the dashboard Java. So down here you get the runner. This is the black box tester, which we talked earlier about, and it will run your dashboard and see if it gives you the proper output. If it does, then your dashboard passes the black box test, and you can submit it to Adhesive, and hopefully it works. So let's open up this dashboard Java and the other one. I saved them in my adhesive folder. So if I open up my adhesive folder, Unit 5, I have dashboard Java and student runner Java. I'm going to take those and put them in my quarter 3 demos. Hopefully they're not there already. Student runner, student clocks, no, they're not here. Good. So I grab dashboard.java, I just drag it over and stick it in my source file. And it says, do you want to copy the files? I do. And then the other one I'm going to do is the student dashboard runner, which I also drag over and stick into my source file. Just take a look at the dashboard Java itself. And this is what you get from Adhesive. So we see the skeleton of a dashboard class. Adhesive has the name of the class already for you. It has 3 attributes for you already, and a bunch of methods for you. Anything that is public is part of the public interface of the class, and these are the functions and constructors that we are going to test with our black box test. So let's look at the black box test. That is the student dashboard runner Java. This will test our file. And so we see in here we are creating new dashboards and then printing them. Notice that the printer here is using the ToString function of the dashboard class in order to print it. So we can take a dashboard and throw it at print line. The ToString function will convert the dashboard into a string, which is then printed. So looks like the runner might run by itself, so let's run this thing and see what happens. Errors exist in the required projects. Proceed with launching. Q3 demos, no. So there's some error in here that's failed. It says one item is an error. The field student ID is not visible. It's running the wrong thing. Proceed. Terminate. Student dashboard runner ran, and it's printing nothing. Oh, here we go. It's printing all these dashboards, but it doesn't print anything inside the dashboard. So we see that the black box test runs and fails. It does not produce the desired output. So let's walk through it and see what we need for a dashboard class. Constructors. Let's see. Add the following constructors and methods. We're adding the default constructor called dashboard. If we look at the dashboard class itself, the default constructor is up here, and it says missing code, so we have to fill in the missing code. This is like getting a brand new car. It's not moving and has no miles on it, so both odometer and speedometer should be set to 0. The check engine should be off. So we have Odometer and speedometer, both of those should be set to 0. The check engine light should be off. Odometer is 0. Speedometer is 0. And the check engine light, check engine, is off, false. I'd love to print this out, so let's run this again and see what happens. If I run it again, still nothing prints. In order to print it, we need the ToString method. And right now, I want to know, does my default constructor work? Is this correct here? But in order to test that, I need the ToString method. So we're going to make the ToString method as well. Currently, the ToString method is returning nothing. If we scroll down, we see the ToString method down here. It says the ToString method displays the current reading of the speedometer, odometer, and check engine light in the following manner. The odometer reading must always have 5 digits, even if the miles driven take fewer. So let's write this down as a comment above the ToString method. So we're going to make a comment above the ToString method. /** starts a multi-line comment. Pressing enter completes the multi-line comment, and now we can copy and paste what the ToString method is supposed to do into our comment. So I highlight the description of the ToString method. I press Control-C to copy. I press Control-V to paste. It scrolls off the end, and I don't like that, so I'm going to just put new lines in here to spread out the description. All right, so a speedometer, blank miles per hour. That one's easy. I need a string into which to stick all these outputs. So I'm going to make a new string, and we'll call this the return string. We'll set it starting to nothing. And instead of returning a blank string, we'll return the return string. This allows us to fill the return string with information. And there are 3 parts. We need to print the speedometer. And the format is speedometer, space, numbers, space, MPH. We need to print the odometer, and the format is odometer, we need 5 digits here, 1, 2, 3, 4, 5, so this can be kind of tricky. And the last one we do is we print the check engine light, and it's going to be check engine, space, either off or on. So the first one and the last one are easy to do. Let's get those set up, and then we'll work on those 5 digits. So we're going to add to the string the speedometer. So we're going to say return string gets concatenated with the word speedometer and a space, and then whatever speed we're at, speedometer. Did I spell it right? Speedometer, yep. And then miles per hour. And a new line. The check engine light, we have to do on or off, and we can do this in 2 parts. Return string plus equals the word check engine, space, and then either on or off. And we're going to do a ternary operator here. Ternary operator is a question mark colon. So we have a conditional question, what to do if a value that we get if the conditional is true, and then colon a value we get if the conditional is false. The conditional we're going to use is check engine. And if the check engine is true, then we are on. And if the check engine is false, then we are off. Once we add the conditional, let me move this to a new line. Then we're going to add a new line. The last one is the odometer, and the odometer is a little tricky, so I'm going to just guess at it first. Return string plus equals the word odometer, colon, and we need 5 digits here. So I don't know yet how to do 5 digits. How to do 5 digits. So first I'm just going to print what the odometer reads. Odometer plus a new line. So now if we run the code, we should be able to see output from the code. We're going to check the output with the desired output for the black box test. The desired output is here. Looks like I have too many new lines between the two sets. I should just have one new line. So I'm going to remove that last new line that I had in the check engine. All right, so now the spacing is correct. Again, the speedometer is incorrect. I need a space in front of miles per hour. The odometer is off. The check engine line is good. So now the last thing to do is get 5 digits on the odometer. And to do that, let's see. I think I need an odometer thing. Let's see how we're going to do this. Now, an easy way might be to use a formatting. Format string. But I haven't used these yet. So I'd have to look up how to do it. Or we could create our own string of 5 zeros and then write digits into them. So let's do that. We're going to create our own string of 5 zeros and write digits into that. So let's make that a function. And we'll call this plus format odometer. And we're going to pass the odometer to that. So we have a function, and this function is going to create an own string of 5 zeros and write digits into them. So let's make that function, format odometer. This function is only called by other functions in the class, so it's private. The function returns a string. The function's named format odometer. And it takes as an input an integer odometer reading. So we need 5 zeros. That string equals 1, 2, 3, 4, 5. And then we can put digits into this. So let's see, how are you going to do this? I think we just do division. We concatenate it. I know, that's what we'll do. We'll concatenate it. Here we go. So we have ret string plus equals odometer percent 3, 4, 5. Say 1, 2, 3, 4. So how many 10,000s? And odometer So it should be divided by. Percent equals 10, 1, 2, 3. See if this works. And then we do ret string plus equals odometer slash 1000. Odometer percent equals 1000. Oh, I got the round slash up here. Look at that. Now we've done this before. This kind of work. Plus equals odometer divided by 100. And then odometer percent equals 100. And then ret string plus equals odometer divided by 10. Odometer percent equals 10. And then ret string plus equals odometer. And then we just return ret string. All right, so let's see if this works. I have the format odometer. If we look at this, we're just getting the 10,000th digit, then the 1,000th digit, then the hundredths, then the tenths, and then the ones. So we have 5 digits here. We're always going to get a string that comes out with 5 digits in it. If the odometer does not have 10,000, when we divide by 10,000, we get 0. And we return, and then we get the remainder. So let's run this and see what we get. We get an error. So the exception thread main, ToString. The operator plus is undefined for the arguments type string. So let's see, where is this? That would be here, I think. I still think I can get the error. All right, see if that does it. I don't think it will. Same error. So I have a concatenation problem. Doesn't know how to add this. So I need to change this integer to a string. How do we do that? Is it integer to string? Let's find out. Here it is. See if this will work. All right, let's try it again. Nope, still error. Java 43 dashboard, Java 43 ToString. It's mad here at this plus. Doesn't know how to turn format odometer. Format odometer returns a string. Doesn't know how to. Oh, there's 2 pluses. This is what it was mad at. 2 pluses. Not down here. Let's try it again. There we go. Bunch of zeros for the odometer. 0, 0 off. 0, 0 off. 99, 1500 off. So this one's failing here. Dashboard number 2. So our second test failed. If we look at our second test, we have a parameterized constructor. And it's failed because we haven't created the parameterized constructor. But my printer seems to be working. I'm getting 5 digits for the odometer. The next thing to do is to get the parameterized constructor to work. So we go to the constructors. I have my parameterized constructor here. It takes two ints, O and S. Notice that they named the parameters O and S, which are different from odometer and speedometer. And this will get around the problem of which odometer do we need. So in the missing code, we just set the two. Odometer equals O, and speedometer equals S, and checkEngine must be false here. CheckEngine equals false. Here we go. The checkEngine light should be off. If miles traveled is between 0 and 999, set the odometer to miles traveled. Otherwise, set it to 0 and turn the checkEngine light on. If speed is between 0 and 100, set the speedometer to speed. Otherwise, set it to 0 and turn the checkEngine light on. CheckEngine light should be off if both values are valid. So let's write down the behavior of this parameterized constructor. And we'll stick it in comments above the parameterized constructor. So we make comments first, /*, enter, Control V. Split it so we can see everything. Parameter O is miles traveled and is between 0 and 99999, positive. S is the speed, and it is between 0 and 100. So far we're not testing for that. We turn the checkEngine light false, and let's do those two tests. So the first test is, if miles traveled is between 0 and 999, use it. Otherwise, set it to 0 and turn it off. So let's see if it's not in the range. So if the odometer is less than 0, or the odometer is greater than 99999, then we are going to set it to 0, odometer equals 0, and checkEngine light goes on. CheckEngine goes on. Similarly, for the speedometer, we want the speed between 0 and 100. How much time have I been going? About 20 minutes. I can go a little bit more. I'm going to leave the rest to you. Okay, go on. Okay, speedometer. Okay, so can someone tell me what is the conditional for this second if? I want to make sure the speedometer is between 0 and 100 and do the stuff that I need to do if it's not. So what do I check for? Okay, if the speedometer is less than 0, go ahead, what else? Or greater than 100, speedometer. It's greater than 100, then what do I do? I set the speedometer to 0. And what else do I do? I turn the checkEngine light on. And an on light is true, right? It's a Boolean. It's either on or off. Okay, so that should work. Let's run this and see if the output looks like what they expect. And I run it. Oopsie. What happened? Okay. Oopsie. Here we go. So we have a look at the output of their test driver. For dashboard 1 is 0, 0 and off. Dashboard 2 is 99, 1500 and off. Dashboard 3 should be 99, 1500 and off. So something happened on the second part of dashboard 2. So this part here failed. And last one, 0, 1500 and on. This step here also failed. So let's look at the test and see what's going on in the test. I think we're using the add functions here. So in the test, after we create the new dashboard and print it, Then we do accelerate twice. And accelerate will change the dashboard, and we should see the miles per hour changing. As it does in the example, miles per hour changes. And eventually we blow the engine up and the engine light turns on. So let's look at the other new lines, or the new dashboards. So dashboard 3 probably works. Let's look at dashboard 3. Dashboard 3 should be 45 miles per hour, 0 odometer and on. It's true. Dashboard 4 passed. Dashboard 5, 0, 2500 and on, passed. Dashboard 6 passed. Dashboard 7, we have 60 miles per hour, 0 and off. 60 miles per hour, 20 and off. So dashboard 7, the add failed, but the brand new dashboard worked. So it looks like our constructors are working, and we can move on to the next methods in the class. The next methods we're going to use are accelerate, and the other method we're going to use is drive. So let's look at accelerate first. Here we have accelerate. It has no code in it. It has the missing code hint that we need to do something here. Let's add comments for accelerate, /*. Go and find the description of accelerate in adhesive and paste it above the method. Void accelerate. Increases the speed of the car by 1 mile per hour. The car accelerates above 100 miles per hour. The car should stall out and go back to 0, and the check engine light should come on. So we're going to paste this in here. Now do notice that we have the same test we did when we did our parameterized constructor. We want to turn the check engine light on if the car accelerates too fast and the engine blows up. So let's do, instead of doing this check here for the speed and the check here, for the odometer and the check here for the speed, we're going to make little functions for these. So we're going to make 2 little functions. And the first function is private void check odometer. And all we're doing in check odometer is taking our if and sticking it in check odometer. So we have our odometer check goes in check odometer, and we'll put that here. Check odometer. We want to do a similar thing for the speedometer. Check speedometer. So we create a new function called check speedometer. There's also a private void. And we're going to move the if statement down there. Can someone tell me why am I creating these private functions? Go ahead. So no one can change it. That's why it's private. But why am I making these private functions? Why don't I just put the code wherever I need it? That's correct. So I only want to, if I have to maintain this and fix it, if something's wrong with it, I need to change it in more than one spot if I put the code in more than one spot. But here, I've made it into functions. I can call the function more than one spot, but I can fix the code in one and only one spot. And that's the reason why you make methods. So now we're going to go to accelerate. Accelerate says, increases the speed by 1 mile per hour. That's easy. Speedometer, ++. And then if the car accelerates above 100, the car should stall out and go back to 0, and check engine light should come on. And that's easy. What do I do here? What function did I make to do this last part? Check speedometer. That's easy, right? So let's do drive. Here's drive number of minutes. I'm going to copy the description. We're going to do the drive here. /** to do the comments. Control V to paste the comments in here. This is a pretty big one. Press returns in here to make all the comments fit on one page. And it says, drives the car for num minutes at the current speed, updates the odometer accordingly, rounded down to the nearest mile. The odometer reading cannot exceed 999. If this happens, it rolls back to 0, and check engine light comes on. Num minutes will not exceed 720 minutes. For example, if the current speed is 60 miles per hour and num minutes is 20, then the car will drive 20 minutes at 60 miles per hour equals 20 divided by 60 times 60 equals 20 miles. The odometer reading should increase by 20 miles. So we can do this. The odometer plus equals num minutes times speedometer divided by 60. Now num minutes is n, not num minutes, it's n. And n is our num minutes. We have to make sure n does not exceed 720. It doesn't say what happens if it does exceed 720. So let's say if n is greater than 720, we'll just set it to 720. N equals 720. All right, so let's test this, see what we get. Oh, I forgot one thing. What did I forget? What did I forget in the drive? I have to check to make sure I haven't driven farther than 99,999 miles. And if I had, then I make it 0 and a check engine light comes on. How do I do that? Check odometer. All right, let's run this, see what we get. So now we're going to check the output versus their canned output, see if we match. Dashboard 1, 0, 0 off. Dashboard 2, 99, 1500 off, then 100, 1500 off, then 0, 1500 on. Dashboard 3, 45, 0 on. Dashboard 4, 45, 0 on. Dashboard 5, 0, 2500 on. Dashboard 6, 0, 300 on. Dashboard 7, 60, 0 off. Then 60, 20 off. Dashboard 8, 60, 99,999 off, and then 60, 0 on. So it looks like their Blackboard test tests all their constructors. Their Blackboard tests both their accelerate and drive properties. I think I'm done. I'm going to copy and paste this into Adhesive and see what I get. So I go to my dashboard class. I do Control A to select everything, Control C to copy. Then I go to Adhesive's submission box. I do Control V to paste. Then I click on Run and see what happens. It's thinking. Passed 5 out of 5 challenges, 100% perfect. Yay. So now the one thing that I see that Adhesive missed, it says num minutes will not exceed 720 minutes, but it doesn't say what to do if they do exceed 720 minutes. So I set mine to 720 minutes if it exceeds 720 minutes, and it doesn't say what happens if they drive backwards. So if the minutes is negative, it's going to go backwards. Maybe they don't want to do that, but it doesn't specify it in what we need for drive. When we create our drive, it fits Adhesive's black box, and it hits their challenge. So I'm going to call this done and not fix those things. And that concludes this demo. Let me do a brief summary. In the adhesive challenge, we have two files, dashboard Java and student dashboard. The dashboard is a class and encapsulates the dashboard in the car. It has how far you've gone, an odometer, how fast you're going now, a speedometer, and a check engine light that is either true on or false off. You are to create the dashboard default function, default constructor, which sets everything to 0 and check engine light off. You are to create the dashboard parameterized constructor, which sets the odometer reading and the speedometer reading. The odometer reading and speedometer reading must remain in a certain range. If they are outside the range, then the check engine light comes on and they are set to 0. You're to make a ToString function which prints exactly a single dashboard in the format that they give. And that format is speedometer colon, how many miles per hour, odometer with 5 digits always, and check engine either on or off. You're also making an accelerate command. The accelerate command adds 1 to the speed and checks to see if you've overspeeded. The drive command drives for a certain amount of time, adds the distance traveled during that time to your odometer, and checks to see if the odometer has overdone. Adhesive has also given you a student dashboard runner, which is a black box test for your dashboard class. When your dashboard is correct, the output from the black box test will match exactly the printed output that Adhesive gives you. So we see we have inputs, processing, and outputs. This black box tests your unit or tests your object by getting inputs in and seeing if the expected outputs come out. In our case, it did. I submitted it to Adhesive, and we got full credit. When you submit yours, make sure you press Submit Assignment button so that I can grade it. This concludes the dashboard demo. Any questions?